Alright, so this is 3.6a. It's applications of linear equations and modeling. So this is pretty much just applications. First application we're going to have is interpreting a linear equation. In other words, if I give you a linear equation, or if we see a linear equation, or if we've created an equation from data that we've been given, then what can we do with it? So that's kind of what we're doing right now. I've changed my display in my Smart presentation, to have dual page, because on the page, you'll see on the page on the right, which now is the page on the left, there's not a lot of room to write on. So we're going to interpret the data here, and I'm going to write on the right side, and hopefully we'll be able to see it. If we can't see it, then I might have to modify things a little bit. If you're watching on a camera phone or like a mini pad, I would say maybe move to a, well, let's see, move to a larger screen maybe. All right. So here's my interpretation. So here's just some information about what we got. On the left, I'm going to go through what we should read on the very top left. From 1900 to 2005, the number of tigers in India decreased. The decrease can be approximated by the equation y equals negative 350x plus 42,000. So there's kind of an equation, a linear equation in two variables. The variable y represents the number of tigers in India, and x represents the number of years since 1900. So that's going to be important, since 1900. So we'll be able to we've defined our kind of data based on since 1900. So I'm going to go to question A. So here's kind of our setup. Here's our linear equation and two unknowns. And oh, by the way, y represents the number of tigers. And by the way, x represents the number of years since 1900. It's important to note that that's since 1900. All right, so question A says, use the equation to predict the number of tigers in 1960. Well, we can kind of take a look at this and say 1960, because this is 60 years past 1900, means 1960 is right there. So we can say that it's, boy, if we're interpreting it from the graph, we'd say it's more than 20,000, less than 25,000, probably pretty close to 20,000. So I'm going to guess about 21,000. But you know what? We can be a lot more precise than about 21,000 by going here and saying, well, use the equation. So we're going to start with the equation. Y equals negative 350 x plus 42,000. All right, so there's our first step. Use the equation. All right, so predict the number of tigers in 1960. Well, let's see. What information is here? Number of tigers since 1960, or sorry, in 1960, means that our x is, let's see, the number of years since 1900, so that would be x equals 60, right? Because x equals 60 means we're 60 years past 1900, which is 1960. All right, so then we can just substitute x equals 60 over in this equation and say, let's figure out what y, the number of tigers, is. Y equals negative 350 x, oops, sorry, x is 60 plus 42,000. Y equals negative 350 times 6. Holy cow, I got to kick a calculator. 0, 0, 3, 18, 21. Negative 21,000 plus 42,000, and that y is equal to negative 21,000 plus 42,000 equals 21,000. All right, so what is y equal to? Y equals 21,000. Y is the number of tigers in India, and that's in 1960, because it's 60 years past 1900. So in 1960, 60 years past 1900, we have 21,000 tigers. And you know what? That was pretty darn close to our guess. We guessed it was about 21,000, but it might have been something really funky, 21,010, something like that, because it depends on what comes out of the calculation here of our linear equation. We can get very precise with this information. All right, so there's our first question. Let me see, B now. Use the equation to predict the number of tigers in 2010. 2010, well, you know what? 2010, let's see, that would be 100. That would be x equals 2010 minus 1900, because it's how many years past 1900 is our x. So x is the number of years since 1900. Well, it's going to be 2010 minus 1900 equals 110 years. Well, 110 is not really represented here. We could probably estimate like down here and assume that it's going to kind of keep going like that. So at about 110, we're going to say maybe about 5,000, or sorry, about 4,000, maybe about 4,000. But we can be precise. We can be more precise because we do have something here. So it says use the equation. All right, we start with y equals negative 350 x, sorry, x plus 42,000. And we said that our x was 110. So y equals negative 350 times 110 plus 42,000. All right. So y equals negative 350 times 110 plus 42,000. Negative 350 times 110. There's a 0, there's a 0, there's 3, 8, and 5. Negative plus 42,000. Ask me how I got that 385 there, and I'll tell you. Subtract, and we get 3,500. Pretty darn close to what we guessed, about 40,000. But again, there's 3,500 tigers in 110 years after 1900, or in 2010. So there we can be more precise. Our guesstimate was about 4,000, but that was again a guesstimate. So let's go to question number C. Question C says determine the slope of the line. What's the slope of the line? Well, let's see. How about C? Y equals mx plus b equates to y equals, right over here, what's our equation? Negative 350x plus 42,000. All right, well, that means that slope m equals, because we're determining our slope. What's our slope? Negative 350. Or negative 350 maybe over 1, and that will maybe be helpful to kind of take a look at that. So that's our slope, negative 350. All right, great. Now interpret. That's probably the hardest part. What is the meaning of that slope in terms of tigers and years? Well, remember that slope is rise over run, and what's, well, like, we can even put rise over run. It's also the change in y over the change in x. What's the change in y? Change in y, or the rise, would be the number of tigers. Let's see, if we're decreasing here, this is the decrease in number of tigers. Decrease in number of tigers, or change maybe in the number of tigers. Change is negative 350, so that means we're decreasing over 1. What is 1? 1 is the change in x. That means that for every 1 year that we go forward, we will have a decrease of 350 tigers. So, in other words, the slope of negative 350 means that we will have a decrease of 350 tigers, for every year that goes forward after 1900. 0 is our 1900 year. Okay, last question. Let's see if I've got black here. Black ink, sure enough. D, determine the x-intercept. Well, let's see, y-intercept would be where this intersects right over here, but we don't care about that. I guess we care about it, but we're asked to find out what the x-intercept is. X-intercept would be right over here, and again, it was probably, we had to guesstimate that it was probably right over here, but it's probably going to be pretty close to maybe 120. So our first step, determine what our x-intercept is. Here's D. What's our x-intercept? X-intercept happens when y equals 0. So in terms of our linear equation that really gives us information about the number of tigers per year, we can say that we're going to say y equals negative 350x plus 42,000. And we're going to say when y equals 0, we're going to find out what that x-intercept is. So 0 equals negative 350x plus 42,000. And we're going to subtract 42,000, and we get negative 42,000 equals negative 350x, x. If we divide by negative 350, we get x equals negative 42,000 divided by negative 350, and that gives us 120. All right, x equals negative 120. That's our x-intercept. X-intercept happens when y equals 0. So when y equals 0, x is 120, and there it is. Determine the x-intercept. There it is. X-intercept happens at 120, comma 0. And interpret the meaning of that x-intercept in terms of the number of tigers and years. Well, this is an x, this is a y. X is 120 means that 120 years after 1900, x represents the number of years since 1900, so that would be in the year 120 plus 1900, 2020, there will be 0. 0 is y, so what does y mean? Y is the number of tigers in India. There are 0 tigers in India. That's what that means. That's the interpretation of the x-intercept in terms of the number of tigers. So what was the x-intercept? 120, comma 0. And what does that mean? Well, 120 years 120 years after 1900, which is 2020, then there will be 0, because y equals 0 means that the number of tigers is 0. There will be 0 tigers left in India. And there we go. That's the interpretation of a linear equation.